Issue of, have I written the law?
No,
No,
ma'am.
ma'am.
No, ma'am.
Ratio. Okay, all of you write down. See, whatever I am teaching you, the theory person, you'll write out whatever I am writing it in the board. Okay, so that no need to refer from the book. Whatever is required for you, I am writing it. All of you write with me. Problems, you can refer it from the book. So the ratio of potential difference between the ends, because while doing the experiment, Ohm found that the ratio of potential difference, PD means potential difference, okay. PD implies, in short, I am writing, it is the potential difference between the ends of a conductor, between the ends of a conductor to the current flowing, to the current flowing between them, current flowing between them is constant. Are you able to understand my handwriting? Actually, my handwriting is not good. All of you,
Ma'am,
you
it's
don't.
clear, ma'am.
It's
It's clear.
understandable, ma'am.
Yes,
It's
ma'am.
clear.
Okay. If there is any problem, you tell me.
Okay, ma'am.
I will tell you. So here he has found that at every instant this ratio is constant. Okay. So if we'll draw the graph between the current and voltage, so this will be a straight line passing from the origin, and this is a constant thing. Okay. So the unit of when he applied the voltage, he has done with a simple circuit. When he applied the voltage into, when he changed the voltage, he observed that the current is also changing. Okay, and at every instant the ratio is remaining constant, provided this is the important thing, provided the physical conditions remaining constant. So always while stating the Ohm's law, always tell that provided the physical conditions constant, physical condition like temperature remaining constant. Okay, so this is what is the Ohm's law. Now, when we will tell that, suppose this is the voltage I am applying 1 volt, at that time the current is 1 ampere, then this resistance value will be equal to how much ohm? This will be equal to 1 ohm, right?
And
So how will you define 1 ohm? So how will you define? So tell me the definition of 1 ohm. When a conductor is said to have a resistance of 1 ohm, a conductor or a substance is said to have a resistance of 1 ohm. Conductor is said to have a resistance of 1 ohm when 1 ampere of current flows in it, when 1 ampere of current flows in it, flows in it, when a potential difference of 1 volt is applied across it. All of you got it or not? This is simple Ohm's law. Understood?
Yes, ma'am.
Yes, ma'am.
So actually we have an Ohm's triangle. This is called as Ohm's triangle. This is V, this is I, this is R. V is equal to I into R, or V by I is equal to how much? R, or V by R is equal to I. Clear?
Right.
This is called as Ohm's triangle. All of you written?
Ma'am, can you tell about the triangle again?
This is Ohm's triangle. V is equal to, the numerator will be equal to how much? The product of these two. Okay.
Yes, ma'am.
And V by I is equal to how much? V
R.
by I is equal to
R.
R. V by R is equal to?
I.
I.
Okay.
Yes, ma'am.
So all of you have written. Next we will go for
Ma'am,
next. Tell.
ma'am, last class you have given one question that what will happen when current passes through that resistance?
Yes. I have asked one question, right? This question I have asked. This question I have asked. I have taken, this is
Yes,
a
ma'am.
10 volt, this is as a 2 ohm.
5
What is
ampere.
the current? Suppose the two ends of the resistor is A and B. While entering into the A, while entering the resistor, the current is 5 ampere. While exiting out from the resistor, the current is less than 5, or it is greater than 5, or it is equal to 5.
Less
How
than
much
5,
is
ma'am.
Less than
Less
5.
Ma'am, less than 5.
or
Less
equal
than.
to less than 5?
Yeah, ma'am.
Equal to
5.
Abhijit told equal. Who is telling less than 5? Who is telling equal to 5? Let
Less
me know.
than 5.
Suprashad, less than 5?
Yes, ma'am.
Okay.
Equal to 5.
Ma'am,
Ayush,
equal to 5.
Equal to 5, ma'am.
who,
Ma'am,
who
equal to
is
5.
Suprashad? Who is supporting Suprashad? Tell. Ankit, Vivesh,
Ma'am, we will apply here Ohm's law, no, ma'am.
you what law you apply? What law you apply? Why it will be less than the current, less than 5 ampere?
Ma'am, because it will, ma'am, the resistor will resist the flow of charge.
It will resist the flow of charge. So no, this here the current will be not equal to 5 ampere.
Ma'am, it will
Ma'am, it
reduce.
will be 5.
Ma'am, it will
Five.
make the current reduce.
Then what is the function of this resistor? Then what is the function of this resistor? What is the function of the resistor then? If it is not opposing the current, then what is its function? Having a conductor.
Ma'am, to flow current in circuit.
What happened?
Ma'am, to flow current in circuit.
To flow current. To flow current. Resistance is there to oppose the flow of current. Resistance is not there to
Ma'am, but when there is no resistance in the circuit, then
current will flow, na? When there is no resistance, when you are purchasing a conductor, you are seeing that how much less resistance it can be. If it is a zero resistance, that is well and good. Okay. Why you will take a conductor means it should have, if it is a pure conductor, it's a good conductor, its resistance would be less. Yes or no? So why resistance? If I'm not putting any resistance here, my current will be equal to 5 ampere, right? Then what is the function? I told you, all of you specifically, you find out the answer and tell me. Why it will be equal?
Ma'am, it will emit heat. The
After
resistor.
you forget about heating.
Ma'am,
You
you told
just
na
tell me it will,
temperature is constant.
temperature is constant. My resistance value is not changing. It's equal to 1.
मैम रजिस्टर सर्किट में वोल्टेज लोअर
See,
करता
see, I am telling you. Just
मैम
after
कुछ इलेक्ट्रॉन हीट में बदल जाए.
I am telling you,
Heat is I square RT, bro. No.
I'm telling you. See, this I have asked you question after I have started the Ohm's law. That means this is related to Ohm's law. Okay. See, when the current will start flowing from the battery, it will consider how much resistance you have connected in the circuit. Accordingly, the value of the current will be determined, right? This 5 ampere current has started flowing from the battery because you have connected a 2 ohm resistance. If you have connected a 3 ohm resistance, the current would have been 10 divided by 3, right?
Yes, ma'am.
Because you have connected a 2 ohm resistance, it has already taken into consideration the resistance itself. That is why the current, 5 ampere current, has started flowing 10 by 2. The 5 ampere current has started flowing from the battery because you have connected resistance. If you will increase the resistance, then 10 by 3. Suppose you increase the resistance to 4, it will be 10 by 4. If you increase the resistance to 10, it will be 1. 1 ampere current will flow. That means resistance is opposing the flow of current, right? Resistance is opposing the flow of current. As you are increasing the resistance, my current in the circuit is decreasing. You are forgetting the Ohm's law here itself. Here only we have applied the Ohm's law, right? VI is equal to I have told you, na, this Ohm's law triangle, Ohm's law equation, V is equal to I into R. So I is equal to V divided by R. This current is equal to 5 ampere. It's because my resistance is equal to 2 ohm and voltage is 10 volt, right? Got it or
Yes,
not?
ma'am.
So if my resistance will be different than 3 ohm, automatically my current will change, right? If I'm taking less resistance, my current will increase. If I'm taking more resistance, higher resistance, my current will decrease. Understood or not? This is only I have given an application of Ohm's law only, right? Here.
Yes, ma'am.
Yes, ma'am.
Okay. So now second, any further doubt? Any further doubt? All of you got it or not?
Yes, ma'am.
It was difficult question.
No, ma'am.
No.
It was
A little
just an
tricky.
application.
Ma'am, again repeat, ma'am. I was having net issues.
It was
Ma'am,
just
that
an
means you
application
are
of Ohm's
asking
law.
the current across the resistance.
I just twisted the question itself. Okay, I wanted to know that. See, I told that how the resistance is opposing. Yes, the resistance is opposing because you
Yes,
are taking the resistance into consideration. My current is increasing or decreasing. The 5 ampere current has flown because it has taken into consideration the resistance 2 ohm. If you would have taken the resistance more, yes. Suppose same circuit, I will put a conductor having a resistance of how much? 10 volt is there. I will put a resistance of equal to 3 ohm. Obviously, my current will be not equal to 5 ohm, right? 5 ampere. Got it or not?
Yes,
Yes,
ma'am.
It will be different then. So here only this question I have applied, I have asked you because this is the application of Ohm's law. Understood or not? Current will be equal to V divided by R. Am I clear to all of you?
Yes, ma'am.
Got it or not?
yes, ma'am.
Yes, ma'am.
So now come to open circuit. What do you mean by open circuit? What is open circuit? What is open circuit? Suppose a circuit is suppose a circuit is there. A circuit is like this. Okay. Just wait. I will put another resistance. So here, this is a circuit, suppose. Suprasad, you got it? The answer.
Yes,
Suprasad,
ma'am. Yes, ma'am. Yes, ma'am.
it was difficult question.
No, ma'am. No, ma'am.
Okay. So here, there are suppose 2 points, A and B. Okay. This circuit is a continuous circuit, but due to some failure or some problem, the circuit is open here. Open means what? Open means there is a break in the circuit. Okay. When there is a break in the circuit, it is called open circuit. And what will be the properties of a open circuit? Tell me. When there is a break in the circuit, it is called open circuit.
Ma'am, no current will flow through the circuit.
Very good. Then second thing. Anyone?
Ma'am, we cannot calculate equivalent resistance of the circuit because it tends to infinity because there is a break in the circuit.
My current becomes zero because there is a open current always pass in a closed circuit, so current will be equal to zero. Okay, so now what is the voltage across this? What is the potential difference across these 2 points? What will be the potential difference? Quick tell.
Zero.
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 सब भूल जाओगे तो कैसे होगा?
Potential difference will be the EMF of the circuit.
Yes, ma'am. V रहेगा. EMF रहेगा.
Will be equal to V.
Yes, ma'am.
Okay, किरचॉफ्स वोल्टेज लॉ पढ़े हो? उसका एप्लीकेशन लॉ नहीं है, ओम्स लॉ है. हाँ, रिमेम्बर कर दो ओम्स लॉ. नहीं, you or किरचॉफ्स लॉ is there. How you are, where you are applying? If you are not applying in this circuit, then what for you have read Kirchhoff's voltage law? So this is, if we'll apply Kirchhoff's voltage law, then what will be my voltage across the AB will be equal to how much? How much? It will be equal to how much? Tell me.
V.
It will be equal to V. So across, when a circuit is open, then the whole voltage in a series circuit. Okay, when a series circuit, when the voltage is circuit is open, the whole voltage will be applied across the which one? Across the open circuit, because there is no potential drop in each of the resistor. Here there will be no potential drop. Am I clear to all of you? Girl student, am I clear? Chetna, Chavi, Pallavi, or
Yes,
कौन
ma'am.
कौन है?
Yes, ma'am.
All of you understood?
Yes, ma'am.
Okay. So here this is an open circuit. Now here I will ask you one question. All of you understood what is open circuit? Now here suppose I have connected 2 bulbs, your bulbs you are using at your home. Okay, 2 bulbs I have connected here. This is one bulb, this is another bulb. So due to these are connected in parallel, so suppose there is a open circuit here. There is open in the circuit. Now what will happen? How much current will flow there? How much? What is the potential difference? Tell me. There is a open here.
No current will flow.
No current will flow.
No current.
So these 2 balls will not glow.
Not glow.
Okay, these 2 bulbs will not glow because this is open. Now second case, another case I am telling you. This is 220 volt. Suppose here I am providing a 220 volt supply. Here I am providing one lamp here, bulb. Another bulb is open here. Okay. Due to some filament, due to some problem, this filament has been open circuited. Then what will be my current?
Half current will half. One bulb will be glow.
This will glow.
Means second
This
one
will-
is
Second one will glow and first one will not.
first one will be off.
Yes, ma'am.
Okay, this is what happens in case of an open circuit, right? Next,
It is not parallel, na? That's why the one will glow. If that will be on side,
Yes.
both will not.
yes, both will not flow. Like in this case, I have told you, na, when current will flow only, it will glow, right? In series circuit, I have explained this one. Suppose here I have connected a bulb, no current is there, so no glow will be there, no potential drop, no voltage. Understood or not? Got it or not? Current is 0, I is equal to 0. Okay, so this will not glow. Series circuit, it will not glow. All of you got it or not?
Yes, ma'am.
Now come to short circuit. What do you mean by short circuit? Short circuit means what? It is a, you have heard that this building was fired.
And due to cross connection of the circuits, it got stopped.
Cross connection, not exactly. If there is a, if 2 things have connected through a conductor which is unwanted, having a low resistance path, there is no opposition to the flow of current. The current has increased very rapidly. Okay, increased to a very high amount. Then there will be a possibility of fire. You have heard in most
Ma'am,
of the
can you
fire
repeat it
cases.
again?
In most of the, my voice is clearly audible, right?
Yes, ma'am. Ma'am, will you
Okay.
repeat it again?
Yes. See, short circuit means it is an unwanted path. Like suppose I am showing you here there are different loads. Suppose can a bulb, fan. I have connected different types of load. Okay. Now what will happen? All the resistance. How much current is flowing here? Suppose this is 2 ohm resistance. This is 2 ohm. This is 2 ohm resistance. What will be my? This is a 10 volt. What will be my current? Current will be equal to 10 divided by 6. Right? This ampere. Clear?
Yeah, ma'am.
10 divided by 6 ampere. You take this as 4, this as 4. Okay. So what will be my 4, 4, 8, 10. So this is my 10 divided by 10 ampere. How much it is? 1 ampere current.
1
is flowing, right? 1 ampere current is flowing here. Now suppose due to any disturbance in the circuit, this resistance, this point and this point has connected. Okay, this point and this point has connected. So what is the, it has bypassed, that means it has bypassed. Here current will always flow in a path where the opposition is, but more current will flow when the resistance is minimum, right? So this one we already know. So now because the current is having a path of zero resistance here, this is 0 ohm resistance. So what will be my current here? What will be the current? Current will flow. Tell me how much current will flow. It will be how much? 10 divided by how much? 6. 6 ampere current will flow. So obviously 10 divided by 6 ampere current is greater than 1 ampere. Yes or no?
Yes, ma'am.
Got it or not? This will be something 1 point something. Clear?
Yes, ma'am.
So now, so what happens? That current, if it is 10 by 6 ampere current, suppose it will, the circuit will not able to withstand, then there is a possibility of fire. The circuit is designed to take 1 ampere of current, right? The circuit is designed to take 1 ampere of current. If the current is more than 1 ampere, the circuit should have that capacity to take 10 by 6 ampere, or this will be 1 point, how much? 2 something. Okay, this amount of current it should have, right? Otherwise, what will happen? There will be a possibility of fire, because due to high current, there will be a possibility of fire. That exactly what happens if you have, when you have heard this building has catched fire due to short circuit. Due to short circuit, always short circuit means this is an unwanted path. We do not want this path. This is an unwanted path. Am I clear to all of you? Got it or not? What is this short circuit?
Ma'am, can you tell?
Which one? I will tell again.
Ma'am, that
Short
last
circuit.
one. Yes, ma'am, short circuit.
This short circuit means here this is an unwanted path has been established due to any failure. Okay, due to any failure, these 2 points have been joined. Okay, and it has bypassed this resistance. So what happens to my current? Current will increase, because by resistance is decreased, implies the current will increase. Understood? That is an unwanted path. We do not want that path. Clear now? Was asking?
Yes, ma'am.
Okay.
मैम तो जो जैसे फायर लग जाती है उसमें, तो रीजन यही रहता है क्या कि अनवांटेड करंट चला गया तो हीट अप इतना ज्यादा हो गया कि आगे
हीट अप ज्यादा, हाँ हीट अप ज्यादा हो करके फायर हो जाएगा, क्योंकि जो ये जो कंडक्टर है ना, कंडक्टर जो है ना, this conductor should have that capacity to take that amount of current, right? This conductor should have the capacity to take that amount of current. If it is not able to take that amount of current, so what will happen? There will be a possibility of fire, right? Got it or not? So a short circuit is a short circuit or a sort of path. It is a sort or a sort is a path of low resistance. Short circuit or short, only short also you can tell. It is a path of low resistance. Okay, it is a path of low resistance. It is an unwanted path. It is an unwanted.
Ma'am,
Yes.
ma'am, short circuit can only be because of high resistance only. Can't it be because of high voltage also?
हाँ, हाई वोल्टेज से तुम्हारा करंट ज्यादा हो जाएगा. सुनो एक चीज यहाँ पर मैं बोल रही हूँ. टू थिंग्स आई एम टेलिंग यू. वन इज सपोज just I'm answering your question. Wait. Now this is a circuit, simple circuit. We will be having a two types of short circuit. One is suppose there is a unwanted path here, this one. This we call it as a partial circuit. Like this is R1, R2, R3. This we call it as a partial short circuit. Why? Because here the current will be there. What will be the current? Tell me. Here the current will bypass the resistance R2. What will be the current? Current will be V divided by R1 plus R3.
R3.
Okay, because there is some resistance, this will called called as partial short circuit. It is called as partial short circuit. Now here in this case, same circuit, but here you see, suppose there is a short circuit like this. These 2 points have joined, bypassed all this resistance R1, R2 and R3, bypassed all this resistance. Then can you tell me at this point? Who was asking question? You tell me. This type of short circuit is called as dead short circuit. Why?
Because there is no resistor, ma'am. It's a direct connection.
Yes, there is a direct connection, no resistance. The current becomes infinitely high. Voltage divided by resistance, that is equal to the current, which is equal to V divided by 0. Current becomes infinite. Understood? This will call it as dead short circuit.
Yes, ma'am.
Most of the cases, all the short circuit which you have heard, as I just told you, in the buildings, fire, it has catched fire. That is due to this dead short circuit. Understood?
Yes, ma'am.
One case.
Yes, ma'am.
So when I'm telling you, when the potential difference will increase, what happens to your current? When potential difference will increase, what happens to your current? When the voltage is increased, obviously the current is directly proportional to the voltage, according to the Ohm's law, right? Right.
Yes, ma'am.
So what will happen to the current? Current
Yes,
will
ma'am.
also
It will
increase.
increase.
See, when the current increases, these conductors, because current is passing through the conductor, right? So these conductors should be able to withstand that amount of current. If that conductor is not capable, suppose here or in our house 5 ampere plug, if you have seen, we are having a big plug size and another one small plug size. Have you seen it or not? You will see that these are used in your geyser. You will see in your micro oven. Yes or no?
Yes, ma'am.
All heating loads. You will see. So this will be, we call it as 5 ampere plug. Another 2 ampere plug. 5 ampere plug. If you connect a geyser with this one, it will burn, right? The conductors will burn. Understood or not? Because this is capable to carry 2 ampere of current. If you will connect a load which is carrying 5 ampere of current, obviously that will burn, right? So when voltage is increased, current is also increasing proportionally. Understood? All of you got it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, next come to voltage source. All of you understood? Anyone having any doubt, you should ask me. I will take a first activity will be a Viva activity. Remember, whatever I am teaching you, I will be asking question on that. Ideal voltage source. First activity will be my Viva activity. You will, whatever I have taught you, I will ask questions from there. So now come to ideal voltage source. Ideal means what? What is a voltage source? Tell me. What is a voltage source? Now suppose I am taking a voltage source of 10 volt. This is providing 10 volt to the circuit. I have connected a load across the voltage source. Okay, suppose that load is, let it is RL. All of you mute yourself. That is RL. Now, if this voltage source 10 volt will be appearing across the terminal, let this is B terminal. If that amount of voltage is appearing across the terminal of the load, these are the 2 points, terminal voltage across the load. Okay, if that amount of voltage is appearing across the terminal, then this voltage is my ideal voltage source. Am I clear to all of you what is ideal voltage source?
Ma'am,
That
again,
means if the voltage source is having 10 volt, if that 10 volt I am getting across the load or across the terminal, then my voltage source is an ideal voltage source. Whatever voltage I am providing, I am getting that amount of voltage across my load, across the terminal. Okay, that is an ideal voltage source. That means what? That should not be according to your Kirchhoff's voltage law, which you have read it earlier. That means there is no drop here, there is no resistance here. No resistance is there because my current will flow. Listen to me very carefully. My current will always be there because my circuit is closed, right? So if there is no resistance, no drop here, then only I will get the terminal, whatever the voltage I am providing it. Am I clear or not?
Ma'am,
Yes, tell.
but RL, there will be a resistance from.
RL I am not taking. I am taking across the load. I am taking across the load, right? Across the load. This is my load. I am taking the voltage across the load. This is my terminal voltage. Okay.
Okay, ma'am.
This is my terminal. So what is my equation? Just to tell me what is my equation. My equation is 10 will be equal to how much? Initially, if I'm not putting this resistance, I'm not putting the resistance here. What is my equation? 10 minus, this is plus minus Vt will be equal to 0, right? So Vt is equal to 10. Got it or not? Got it or not?
yes, ma'am.
Okay, now second case, that means it will happen in which case? If there is no other resistance connected here, that means if there is no drop in there is no internal resistance here. The internal resistance is equal to 0. So if internal resistance is 0, whatever may be the current, let it be 0.00001 ampere or it is 1000000 ampere, whatever may be the current. If my internal resistance is 0, then what will happen? Vt will be equal to 10 volt. If internal resistance will be equal to 0. Whatever may be the current. Am I clear to all of you or not?
Yes, ma'am.
Whatever may be the current. If my current is 0.001 ampere or it is 10001 ampere, whatever may be the current drawn. But if my internal resistance is 0, implies I will get the terminal voltage equal to that of the source voltage. This is my source voltage, right? This is my source voltage. Am I clear to all of you? Got it or not? Got it or not?
Yes, ma'am.
Yes, ma'am.
So how will you define ideal voltage source? It is a constant voltage. It is a constant voltage source. It is a constant voltage source that maintains constant terminal voltage, that maintains constant terminal voltage no matter how much current is drawn from it. How much current is drawn from it? जितना भी वो current draw करे. This will happen only when this will happen only when internal resistance of the voltage source is equal to how much? How much it is?
0.
0.
0.
Ma'am, is it possible to have, ma'am, idle current in our real life? Idle
No,
voltage?
it's not possible. It's not possible.
There will
Ideal
be short
voltage
circuit.
source. Ideal voltage, ideal current source. Okay.
Ma'am,
Then
ma'am, there can also be a one more scenario, no? When when the resistance or loads are connected in parallel, then also we can observe ideal voltage condition.
resistance are connected in
Parallel, then
parallel.
also we can. Yes, ma'am.
देखो
The,
देखो एक चीज तुम एक प्रैक्टिकल चीज बोल रहे हो तो मैं बोल रही हूँ तो I in our home how much would what are the loads are connected in parallel loads are 220
yes, ma'am.
30 volt
Yes, ma'am.
200
Connected in parallel.
parallel 230 volt यहाँ पर तुम बल्ब फैन AC लगा रहे हो suppose this is AC this will also get 230 volt na according to you
Yes, ma'am. Yes, ma'am. Yes, ma'am.
230 volt are you getting 230 volt तो फॉर दैट पर्पज वी आर यूजिंग ए वोल्टेज स्टेबलाइजर देखना तुम्हारे एसी के पास एक वोल्टेज स्टेबलाइजर होगा या नहीं
Yes,
हो
ma'am.
रहा है नहीं उसका
Yes,
क्या
ma'am.
काम है क्यों क्या काम है
To
स्टेबलाइजर
give the proper voltage. If it is
You
low, to
give
give
the
the
तो 230 वोल्ट तो तुम दे रहे हो घर को तो 230 वोल्टेज दे रहे हो फिर स्टेबलाइजर लगा क्यों रहे क्योंकि वहां पर थोड़ा रेजिस्टेंस ड्रॉप हो रहा है ठीक है which we are telling now we are giving a 230 volt this is a resistance so voltage across here we are giving 230 volt that means we are getting 230 volt across these 2 points we are getting 230 volt across these 2 points yes or no we are reading yes or no
Yes, ma'am.
that means whatever the voltage source we are taking now when you are reading it theoretically we are reading that these are ideal we are not taking into consideration the practical thing because we are reading theoretically how we will take in practical thing in the problem if the internal resistance is given implies that that is a practical voltage source otherwise you are solving theoretically when you are reading you are solving all the circuits and considering they are all ideal voltage source am I clear
Yes, ma'am.
am I clear
So,
to all
ma'am,
of you
ma'am, so the other definition you have given, this is also an ideal situation, I guess, because mostly we
which one
don't have internal resistance 0.
this is an ideal case no
Yes, yes, ma'am.
this is an ideal case. Ideal case will be when the internal resistance will be 0. You will
Yes,
never get an ideal voltage source having internal resistance 0. Whatever you are reading, in theoretically, we are considering all the voltage source while doing the problem. We are taking all the voltage source as an ideal one. But practically, you will never get a voltage source as an ideal one. Always there will
Yes,
be some internal resistance. There will be some
yes,
internal resistance. Maybe the internal resistance is very, very small. Usually a good voltage source is having very less internal resistance. So that the drop will be very less. Okay. So that you want that you are, what is the reason why you are using a voltage source? You want that I have connected a load, my load should get that amount of voltage, right? Got it or not?
yes, ma'am. Yes, ma'am.
I have connected an AC. My AC is operating at 230 volt. My AC has been designed. It has been designed. All the components will work at 230 volt. Right. So if my AC is not getting 230 volts, then obviously the reliability of the AC will hamper. Right.
Yes, ma'am.
Understood or not? So
Yes,
whatever. So I have connected a load to a voltage source implies my load should get that amount of voltage. If I'm not getting that amount of voltage, that means there is some internal resistance. There is some internal resistance, so that some drop is there. Even if the drop is very, very less, still some drop is there. So in practical voltage source, some drop is there. It is very, very less because a good practical voltage source will be having very less voltage drop. Understood?
yes, ma'am.
Okay. So this is, I have given you the definition of an ideal voltage source. Now coming to a practical or real voltage source. Practical or real voltage source. Yes. So what will be the definition of real voltage source? Tell me.
Means that internal resistance कुछ
There will
रहेगा
be
मैम
some internal
non zero
resistance,
yeah.
and that resistance should be very, very less. Okay. So write down the definition of real. Yes.
Excuse me, ma'am.
Tell.
Ma'am, could you please show the last line for that definition?
Which one? Ideal.
Yes, ma'am.
Till now you have not written.
Ma'am, my network was lagging, so sorry.
Yes. No, don't tell. Sorry. Written.
Yes, ma'am. Thank you, ma'am.
Okay. So now come to real voltage source. Just wait, I am facing some problem in that board. Yes. So real voltage source is what? Which is having some internal resistance. You see here, real voltage source, or we call it as a practical voltage source. So that means some drop is there. If I am not getting that amount of voltage at the terminal, so this is my terminal voltage. If terminal voltage will be less than 10 volt, when, in which case, when obviously there is some drop in the circuit, right? When there is a drop in the circuit, then the terminal voltage will be less than 10
Yes.
volt. So this is in case of a real voltage source, and this internal resistance is very, very less. Okay, so the definition of a real voltage source is that.
Ma'am,
Tell.
can I explain again, ma'am?
Why your network connection was poor?
Yes, ma'am. Sometimes your voice is, ma'am, is not audible to me.
My voice is not audible.
Ma'am, ma'am, my network issues.
Oh, your network. Yeah, the real voltage source is that voltage source whose terminal voltage decreases when current is drawn from it. Real voltage source has internal resistance, within bracket write down. This internal resistance is actually very, very less. R is very, very less. It should be very less. It should be very less. Okay. Okay, very less. That causes the terminal voltage to decrease when current is drawn from it. Next class I will start the current source. So actually the symbol of the this is your internal practical voltage source. Okay, this is the practical voltage source. Practical or real voltage source. Am I clear to all of you whatever I have taught you today?
Yes ma'am.
Yes, ma'am.
Okay, next class I have taken the attendance. You leave your 5 minutes is there. Wait. Let me start. All of you have written?
Yes, ma'am.